Hello students, this is a review of the Reteach lesson that I delivered the other day. The first question talks about a climate scientist measuring the temperatures during 5 days of January. This is a sequence, and we can tell that it is a particular type of sequence we're adding to each value. So we would call it an arithmetic sequence. The recursive equation for an arithmetic sequence is as follows. It's simply the starting value, which is a1, and then an, which is any term, plus the pattern is equal to a sub n plus 1. So we know that a sub 1 in this case is negative 2. So we'll type in negative 2 here. Just go ahead and slide that in there. And then an plus, well, we know that the pattern is adding 2. So we'll take this 2, and I'll put it in that slot, and we're done. And recognize that there are two parts to a recursive equation. The first part is the starting value, and the second part is the pattern. Next, it asks us to write the explicit formula for the sequence. The explicit formula is found on your reference sheet, and it looks like this. And again, this is straight from the reference sheet. A sub n, which is any term, is equal to a1, which we just said is the starting value, plus n minus 1 times d. That d stands for the common difference. So the first thing we have to realize is that a sub 1 is something we know already. We found it up here, it's negative 2. So we'll throw that into the equation. We also know that d, the common difference, is 2. So we'll throw that in there, and we'll just build the rest of the equation around that. So we have a sub n is equal to negative 2, and then we need a plus, n minus 1 times 2. There's our explicit formula. Last but not least, it asks for using the explicit formula to determine what the temperature should be on the 31st of January. So you need to use the explicit formula that you just determined or just found to find the temperature. So here's the explicit formula. We're just going to take this same explicit formula and we're going to substitute some stuff into it. Instead of sub n, we know that the number that we're trying to put in here is 31. And now I'm going to substitute that in for n as well. And keep in mind that it's 31 minus 1 times 2. That's what that means. The next step is simplifying a little bit. So we'll take this same exact thing and simplify just a bit. 31 minus 1 is just 30. When we've done order of operations, we did the parentheses first. Next thing to do is multiply. So 30 times 2 should give us 60. So we'll fill that in here. And then last but not least, we'll add. So 60 plus negative 2 is equal to 58. So we've reached our answer. A31, the 31st day of January, is going to be 58 degrees. So remember, you're supposed to write that in a sentence. So we can say the temperature, it's easier than it looks here, on the 31st day of January will be 58 degrees. All right. The next question asks us to do a substitution to solve a system of equations. And remember what substitution means. We're going to take the value of y, which is already solved for, 2x minus 6, and we're going to substitute into the other equation for the value of y. So we'll take out y and we'll replace it with what we know it's equal to. So here we have the two equations. We know that y is equal to 2x minus 6. So we're going to take this value, which is 2x minus 6, and we're going to substitute it into y. So instead of writing y, I'm going to rewrite this equation as 2x minus 6 equals negative 2x plus 10. And you see that's exactly what I did. I took out y and I replaced it with 2x minus 6 because I know they're equivalent. Now we're going to do some solving. We need to add the 2x here to both sides. So if I add 2x to both sides, I'll get 4x minus 6 on this side equals I eliminated this by adding 2x on both sides, so equals 10. Now I'm going to add 6 to both sides. So if I add 6 to both sides, this eliminates, and this becomes 16. And then I know 4x equals 16, I have to divide both sides by 4, so I should get x equals 4. That's my value of x, but I need to find the value of y, and luckily I have an equation here that can let me do just that. So this is y equals 2x minus 6. So I'll take the information that I have, which is this, and I'll substitute it in x equals 4. So I'll replace the 2 with I'll replace the x with a 4. 2 times 4 is going to be 8, so y equals 8 minus 6, which is, of course, 2. So now I have two pieces of information. I have the 2 and I have the 4. So x equals 4, y equals 2. So our solution is x equals 4, y equals 2. And we'll write it as an ordered pair. Next, I'll solve the same system of equations using elimination. Remember, elimination means we have to find two coefficients that are opposites, like, let's say, 2 and negative 2, which this system of equations has. So now that I rewrote both equations, you can see that this 2x and this negative 2x, if we were to add these together, they would eliminate. They would become 0. So what I'm going to do is I'm just going to add both equations together. I'm going to add straight down everything that I see. So I know y plus y, that's going to give me 2y. I'm going to bring down the equal sign. I also know that 2x plus negative 2x is equal to 0. Last but not least, I know that negative 6 plus 10 is equal to 4. So I've added together this entire equation with this other entire equation. And now from the system of equations, I have one individual equation. Well, this individual equation is actually pretty easy to solve. 2y equals 0 plus 4, which is 4. And if I divide both sides by 2, I get y equals 2. I can take that information, the y equals 2, and I can substitute it into any equation that I want. I think I'm going to do the first equation because that doesn't have a negative 2. It has a positive 2. So y equals 2x minus 6. I'm going to substitute the value of 2 that I found for y. So 2 equals 2x minus 6. I'm going to add 6 to both sides. So adding 6 to the left-hand side gives us 8. And if I add 6 to this, it eliminates. So all I'm left with is 2x. Then I'm going to divide both sides by 2, and I get 4 equals x. And I want you to notice that we were able to find the solution, which is 4, 2. Sound familiar? It's the same exact solution that we got up here because we used two different methods to solve the same problem. Next was a question on a system of inequalities. The previous one was equations. This one is inequalities. We're asked to identify one solution and one non-solution. Use of the graph is optional, but with the systems of inequalities, you should use the graph. So I've copied the system of inequalities down here, and we can see that the first inequality we can graph right away. With this first inequality, it says that the y-intercept is negative 4, so I'll go ahead and put a point at negative 4. And my slope is 1, so that means I go up 1 over 1. So I'm going to simply go up 1 over 1 here, over and over again, until I get the idea. And now that I've gotten the idea, I'm just going to use a ruler to make a straight line. But before I do that, I'm going to look at my symbol here. That symbol, that's the greater than symbol, means two things to me. The first thing that it means, that greater than symbol, means that you're supposed to have a dotted line. It also means you're supposed to have a shade up, which means I'm going to represent that all of these points up here are solutions to the inequality. So I'm going to do that now. Okay, so you can see my dotted line, and you can also see my shading up. The next inequality is y minus x is less than or equal to 8. You can't solve it. You can't graph this without solving it first, so I have to solve it first. So here's my inequality. Luckily for me, all I have to do is add x to both sides, and I should get y by itself. So I have y is less than or equal to this same symbol, so I'll grab that. Since I added x to both sides, it's not negative x anymore. It's going to be positive x. And the 8 never changed its sign. It was always positive. So y is less than or equal to x plus 8. That means I can put a point at my y-intercept, which is 8. That's up here somewhere. And my slope is positive 1. So that means I'm going to go up here. And I can see the straight line already. Now I'm just going to get a couple pieces of information about the graph. I know that it's this symbol, and that symbol means two things. It means a solid line. Anytime you have the underline, which means equals, that indicates a solid line. And it also means less than. So when you think less, you should think down. Or, in other words, shade down. So that's what I'm going to do. I'm going to draw a solid line connecting these blue points, and I'm also going to draw shade down. And you can see my two different shadings are overlapping here in the center. Now remember what the question is asking. The question is asking to identify one solution to the system of inequalities, and we also need to find one point that does not solve the system of inequalities. So those two things are going to be found on the graph. A solution to this system of inequalities is going to be a point that is in the double shaded region. So any point that's here is a solution. I like to go by my old standby 0, 0. That point in this case is in the solution set. It's in both shaded regions. So I can say that one solution is 0, 0. A non-solution would be a point that's not in the double shaded region, not in the middle here. So we can pick any that's in just red or any that's in just blue. I guess we can choose, like 10 and then negative 10, which is a point that's all the way down here. Let me graph that up for you here. So this point, as you can see, it's in the blue shaded region, but it's not in the red shaded region. So we can say one non-solution is 10, negative 10. So one non-solution is 10, negative 10. Of course, you can see that. It's not overlapped by the shading at all. Okay, we're fine. Next question. This one gives a quadratic function, and it asks you to find the zeros by factoring. And factoring this type of expression or equation, we're going to use the AM method. An AM method, as you recall, oh my gosh, what just happened? That was weird. Let's pretend it didn't happen. AM method, as you recall, requires you to identify the numbers that multiply together to give you negative 24, and that add together to give you negative 10. And what you can do is you can take that negative 24 on the outside here and make a t-chart. And in that t-chart, you're going to identify all the numbers that multiply together to give you negative 24. And eventually, you're going to find the pair of numbers that add together to give you negative 10. So let's say negative 24 and also 1. We could say negative 12 and also 2. And lo and behold, we found our pair only by listing two things. Almost as if I planned it out like that. These two numbers add together to give you negative 10. So if I were to factor the inequality, it would look like this. F of x equals, instead of writing x squared minus 10x minus 24, I'm going to represent it as two factors, x minus 12 and x plus 2. Those are the two factors that I've identified over here in my A&M chart. When I'm looking for the zeros of a function, I need to represent the fact that f of x is equal to, that's right, 0. So I got x minus 12 and x plus 2. Next, I'm going to use something called the zero products property, which means that when I multiply two things together to equal 0, both of them equal 0. So on this side, I'm going to write down 0 equals x minus 12. I can take it out of the parentheses, and the same thing here. X plus 2 equals 0. Now I can solve both of them. In this case, I add 12 to both sides. I get 12 equals x. That's one of my zeros. And on this side, I can say subtract 2 on both sides. I get x equals negative 2. So now I have my two zeros. The next two parts talk about finding the zeros by completing the square and using the quadratic formula. I'm running out of time in this video, but what you can do is do those by yourself and try to make sure that you get 12 and negative 2 as your answer, just like the previous problem. All right, that's all the time I have. Take care.